Okay, so let's give you guys some more practice. So here, find the indefinite integral of this. So press pause and have a go. Okay, so to do this here, at the moment you've got one fraction here. Break this up into two fractions. So here you've got one fraction here, and then take away this fraction here. Okay, so basically this here becomes this, and now simplify. So you've got an x here, cancel that out with this, and then visualize this as x to the power of a half. So that's x to the power of half over x. And then this bit here, visualize it as to the power of a half. And well, anyway, this thing here simplifies to this. And then you've got a half. So you've got x to the power of a half divided by x. So that's like you getting a half take away 1. So that will give you a negative a half. And then this thing here is really a half take away 2. So a half take away 2. So that will give you minus 3 over 2. Minus 3 over 2. And then now, so you are currently here. So now you need to find the antiderivative of this. So you got to find something that when you differentiate it, you got to find something so that when you differentiate it, it will give you this thing here. And then later on, you got to find something that when you differentiate it, it will give you this thing here. So looking at this first, our first guess should be x to the power of a half, because when you differentiate this, it will give you a half x to the power of minus a half, because this thing here gets minus by 1. So look, so this bit here matches up with this. Now you want to get rid of this this half here, so make the adjustment too. Well, anyway, so this bit, so when you differentiate it, looking at this here, when you differentiate it, it will give you this, okay? And then use the same method here. You got to find something that when you differentiate it, it will give you this. Well, your first guess should be x to the power of, well, it's going to be 1 more than this. Well, 1 more than that would be minus a half, because when you hang on. So this would be this here would be our initial guess. When we differentiate it, it will be a half minus a half x, and then this thing here gets minus by 1. So that would be minus 3 over 2, because minus 1 would be minus 2 over 2. Well, anyway, when you differentiate it, it will give you this thing here. Okay, but you don't want this a half. You do want the negative here. So you make the adjustment of making this a 2. That will then kill off this a half, but maintaining the negative here. So that's this negative here. Well, anyway, when you differentiate this, it will give you this. When you differentiate this here, it will give you this here. So now add your constant. So you finding the indefinite integral of this will give you this. So now tidy this up, and it will give you this. Okay, so this is your final answer. But now let's just double check. If you were to differentiate this here, you should get back to the original here. You should get back to this. Okay, so hang on. So this is your final answer here. But then let's check. Let's differentiate this just to see if we will get back to the original. So if you were given this and you were asked to differentiate this, you would then do this. Hang on. So you're asked to differentiate this here. So we are really just double checking everything. So visualize. So you've got to differentiate this. Visualize this thing here as this. Okay, and then differentiate it. It will give you this goes down here. That will kill off each other, and then blah blah blah. Differentiate this. It will give you this. Differentiate this. It will give you this here, and this is a constant. When you differentiate it, it will be 0. Okay, so it's like asking you to differentiate a constant, a number 7. When you differentiate the number 7, it becomes 0. Well, anyway, if you differentiate this, it will become this, and then rewrite this as to the power of rewrite this as this, and then this will become this, and then now you want to get the two denominators to be the same. So the way you get the two denominators to be the same would be to times top and bottom by x to the power 3 over 2 times the bottom here by x to the power 3 over 2, and then over here times top and bottom by x to the power of a half, and then now 1 times this will be this, x to the power of half times x to the power of 3 over 2, blah blah blah. That would then give you this, okay? And this is like 4 over 2 is really squared. This is really x squared, okay? So hang on. So then yeah. So when you tidy this up, it will be this, because this is x squared, and then for this bit here, visualize this thing here as a block of x times x to the power of a half. Okay, visualize this thing here as this thing here. So this x here is this bit here, and then this is your square root of x, and then blah blah. This becomes this here, and then merge the two fractions together. It will give you the original. Okay, so this was the original. So yeah, okay.